Hi, today we're looking at combining like radicals. Very similar to what you did in kindergarten when you were counting. Okay, so if I look at this picture with that little plus sign in between them, it means I'm going to put those groups together. And when I do that, you see here I have 1 duck and 3 ducks. So putting those groups together, I have indeed 4 ducks. That's what we're doing. The only thing is we're not counting ducks. We're not dealing with variables. If I was doing that with variables, that would be d plus 3d equals 4d. Again, I would be reading that 1 duck, that's the first d, plus 3 ducks is equal to 4 ducks. Okay. Same things have to happen with radicals. So let's get the ducks out of the way. And you see in the first term I have 1 radical 2. In the second term I have 3 radical 2's. And indeed, when I put them together, just like in kindergarten and you were counting, you have 4. For what did we count? Radical 2's. So remember, addition and subtraction is counting what you have. Coefficients tell you what you have. Radical 2's are what we count. So these are called like radicals, and we can count them. So let's try a couple. Again, do these real quick, and then check back. So pause it, do them, check back. Okay, here comes the explanation. By now you should have already done these. So let's take a look at how they went. You had negative 3 square roots of 5, another negative 4 square roots of 5. That means you have negative 7 square roots of 5 are what we are counting. Here you have 1 square root of 10. Here you have negative 5 square roots of 10. When we put together the positive 1 and the 5 negatives, negative 4. And again, we are counting square roots of 10. Okay. Our next page. Now we're going to look at what happens if they are not the same. So here we have a problem because we have a whole group of ducks, and I want to take a frog out of that group. That's what we have in the middle there, that taking away. So here's the problem. That frog is not what we want. Well, luckily we have a beautiful square root princess. She's going to come in and kiss our froggy here. And when she kisses our frog, look at that. It turns into a couple of ducks. Okay, so our frog goes away, becomes 2 ducks. Throw our froggy princess to the side. And now we can take away. So this says I have 7 ducks. I'm taking away 2 ducks. And that leaves me with 5 ducks. Again, if we were actually doing the taking away, I would be pulling them out of here, and I would be left with 5 ducks. All right, so let's move our ducks all out of the way and actually look at what this problem looks like for real. Okay, so currently I can't put it together. But when we look at the square root of 12, we'll notice it's not simplified, because it has a perfect square factor. That's our princess, our perfect square princess of 4, together with a factor of 3. Both of those are currently under the radical. Now that square root of 4 is going to walk through this doorway, and it comes out a 2. So I have 7 square roots of 3 minus 2 square roots of 3. So 7 minus 2 equals 5 square roots of 3. So again, before you can combine them, you have to make them like radicals, and that happens when you simplify. If they're not like radicals, you can't put the terms together or take them apart. You can't add or subtract things unless you have like terms. In this case, we're counting radicals. So look at these two. They will simplify. And then once they're simplified, they will be like radicals, and you can add or subtract them. Give them a try. And again, come back and see how they're done. All right, so let's take a look at how they were done. You should have done them already. You should be checking your work. So here we have 3, and then the square root of 20 is square root of 4 times the square root of 5 plus 2 square roots of 5. Again, because 5 times 4 gives me 20. Both of them are still under the radical because the 20 was under the radical. Now that 4 is going to come through this magic door. 3 times 2 times the square root of 5 plus 2 square roots of 5. Again, we did the square root of 4, which is equal to 2. We know that, because 2 times 2 is 4. Now that that's outside from under the radical, it will interact with this factor of 3. So I get 6 square roots of 5 plus 2 square roots of 5 Now I have like radicals, and I can count them. If I have 6 of them, and I have 2 more of them, together I have 8 of them. 8 of them, and then what I'm counting here is square roots of 5, not ducks, like we were counting in the first slide, and what you counted in kindergarten. So no difference here, okay? Addition and subtraction is counting, coefficient tells us how many, and we're counting square roots of 5. Here we want to subtract, so we have 3 square roots of 3, nothing can happen there. Minus 2, square root of 27 has a perfect square factor of 9. Perfect square factor. 9 is a perfect square, and 9 times 3 is 27. Both of those factors still under the radical, because the 27 was under the radical. So I have 3 square roots of 3 minus 2 times 3 times the square root of 3. Again, here is where we're keeping track. This is that special point where that 9 goes through the door and becomes a 3. The 4, square root of 4, becomes a 2, and it goes from functioning under the radical now to being able to interact with things outside of the radical. Has to go through that square root door. Okay, and once it goes through that square root door, it works with stuff outside. So I have 3 square roots of 3 minus 6 square roots of 3, and now I'm ready to deal with my square roots of 3. 3 positive square roots of 3, 6 negative. When I put together 3 positive and 6 negative, they fight. The negatives win by 3, and those are square roots of 3. That's what we were counting. Okay. We can also use the distributive property. So if I'm going to distribute, it's just now putting together what we did before. 3 times 6, again, they can interact because they are under the radical. So 3 times 6 is 18, and that would be under the radical. Now I have the 3 times the 7. Those cannot interact. I can only write it 7 times the square root of 3. Then I can deal with the 18. 18 simplifies. There's a square root of 9 times the square root of 2 plus 7 square roots of 3. I end up with 3 square roots of 2 plus 7 square roots of 3. And I cannot go any further. I have ducks and I have frogs, and there is no more magic princess to change one. They are already simplified. Okay, so there is no way to go any further with this. That is our answer. If they were like radicals, then we could go the step further and put them together. Okay. Here are some problems to try. Give them a try. All right, so we should have these 3 done. The answers are going to be up in a minute, so make sure you have them all done. All right, so here's what it should look like. Again, the first one, just a quick review of this work that's up here. We distributed the 5 to the 2 terms in there. Again, these can't interact. One's outside the radical, one's underneath. These 2 can interact because they're both underneath. And then we have to simplify the 50. Okay, and we cannot combine them at the end. They're not like terms. Again, as we do this, the ones underneath the radical interact, and then it can get simplified. The ones, when they're not under the radical, cannot interact. You have its own term. Here's kind of a special case. You had 5a, square root of 5a times the square root of 5a, which we talked about before, comes out 5a. Again, if you did the multiplication, it would be 25a squared. Take the square root of those are both perfect squares, so they walk through that door to give you 5a. And in our second distributing, they do not interact. So everything we're doing with radicals is the same thing that you've been doing before. If you have to multiply binomial times a binomial, then that's our next step. Again, there are 4 products that we have to find. We can use the word FOIL to help us keep track of them. Multiplying your first terms. So this one should be copied down as we do it. So you have radical 5 times radical 5. I could just write down 5. Okay. Again, where that 5 came from, radical 5 times radical 5 would equal radical 25, which comes out 5. Then we have our outside terms. You have radical 5 times 15. So 2 15s is 30, 4 15s is 60, and another one, square root of 75. Then you have these inside terms. You have a negative times a positive. This actually came out positive. This will come out negative. The 2 is not going to interact with them, but the 15 and that 5 can interact to square root of 75. And then, of course, we have our last terms. And this one, again, is going to be one of those special cases because you have the 15 times the 15, and radical 15 times radical 15 just comes out 15. You don't have to go to the square root of 225 and come back to 15. So I'm going to have negative 2 times 15. So, finishing up this problem, 5. Square root of 75. We recognize that that is 25 times 3. Again, that was under the radical, so both of those are still under the radical. Minus 2. Again, that's square root of 75, square root of 25 times the square root of 3. And last, minus 30. Next line, still have this 5. Square root of 25 becomes 5, and those are square roots of 3. Here I have minus 2 times 5, square roots of 3. And last I have minus 30. 5 plus 5 square roots of 3 minus 10 square roots of 3 minus 30. Again, I'm showing you each step individually. You could skip a couple of these steps, like you might go from here, say to here, without showing this red step in the middle, shorten up your work a little bit. Last thing I'm going to do, combine our like terms. Okay, we have constants here. 5 and minus 30 comes out negative 25. And then we have these radical 3 terms, so we're going to count them. You have 5 positive radical 3's. You have 10 negative radical 3's. So 5 positive, 10 negative gives you negative 5, and we were counting radical 3's. We can't put those 2 terms together. This one is rational, that one is irrational. That is 5 radical 3's. This one is 25. So we are done. Okay? There's a few more problems to practice. Okay? And that will wrap up our notes when you're done with those 2. So get those done, check back, make sure you pause. Answers will be coming up soon. Okay, so in this problem again, we have 4 things to multiply. First, outside, inside, last. I color-coded each of them so you can keep track when you look at it. If you need to pause and take some more time to see where everything came from, do that. This is what your work should look like. Okay, look at each of your 4 products. Make sure they match what we have here. Again, remember that factors under the radical interact with factors under the radical. Factors out from the radical interact with factors out from the radical. Then we want to simplify. In both of these terms, we have the square root of 18. That becomes the square root of 9 times the square root of 2. Square root of 9 goes through the doorway and comes out of 3, which is multiplied by the 10 to give us 30 square roots of 2. This square root of 9 goes through the doorway and comes out of 3, multiplied by the 3 that's here, gives you 9, still square roots of 2, and then you're simply combining your like term. Positive 12 with negative 45 gives you negative 33, and negative 30 with positive 9 gives you negative 21. Again, here is a rational term, here is an irrational term where you count the square roots of 2. Okay? Again, you should try the next one. If you're getting stuck on the way it looks here, remember what that means is the square root of 7 plus 4 times the square root of 7 plus 4. So there are still 4 things to multiply, 4 products to get, just like there were in this example. Okay, make sure that's done, come back and check it. All right, so we made ourselves a little bit of room. Again, 4 products. The first, square root of 7 times the square root of 7 comes out 7. You've seen that a bunch of times before. Inside and outside are the same. 4 square roots of 7, 4 square roots of 7. That's your inner and outer terms. And last one, you have the 16 at the end. Square root of 7 doesn't simplify, so now it's easy. We're simply combining the 7 and the 16 to get the 23, and then you're counting your square roots of 7. 4 square roots of 7 and 4 square roots of 7 is 8 square roots of 7. That's it for this lesson. We'll see you in school. Good luck.